Hi, in this video we are going to see about a Python IEEE project which is entitled as AI powered Alzheimer's disease detection using deep learning, which is an enhancement of IEEE base paper title design of CNN Swin transformer model for Alzheimer's disease prediction using MRI images, which is an IEEE 2025 journal paper. So before seeing the execution of the project, let me brief about this project. So we all know our human brain is one of the important organ. If there is any problem happened in the human brain, getting identified and getting diagnosed with it is a very critical thing, as it is surrounded by lots of neurons in it. So here Alzheimer's disease is also one of a thing that is happening in our human brain, which is a neurological disorder, and also this is a progression disorder, which means that when if an Alzheimer's disease is occurred, so it will be increased day by day. So every day the stages will be increased in it. So identifying this Alzheimer's disease yearly will prevent the human so that they cannot get affected more in it. So nowadays artificial intelligence is implemented in all the domains, especially in medical fields, due to their capacity of identifying the things with the large number of images processing in it. So in this base paper, the authors have introduced the CNN model for identifying the Alzheimer's disease in it. So here they have used MRI images. So based on the data set that is publicly available, so they have used OASIS data set, and in this project they have introduced the XWin XNet model, which is a fusion of the efficient net B0 and Swin transformer. So here they have achieved accuracy around 95.3%. So here you can see the complete details of the data set on the base paper. So here you can see there are 4 classes available: non-demented, very mild demented, moderate demented. So and here the data set contain images around 2600 for each classes in it. So these are all the things that is available in the base paper part. So now kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system and also how we have improved from the base paper and our contributions in it. So our proposed title is AI powered Alzheimer's disease detection using deep learning, and this is the IEEE base paper title, and this is the IEEE base paper abstract. So now before seeing our proposed abstract, let us see about our proposed models that we are going to use in it. So here we are using 2 different models. One is MobileNet architecture and another one is Inception v3 mobile architecture. So here for the first model, MobileNet, we have achieved the training accuracy of 99% and test accuracy of 98.35%. And coming to the second model, Inception v3, we have achieved the training accuracy of 99.48% and test accuracy of 94.25%. So this is our proposed system model. So we have improved from the base paper. And also coming to the data set part, so we are going to have the more number of data set features. So now let me show you the data set. So here in the data set we have the test, train and validations of it. So now in the train part we have 4 different classes, that is mild demented, moderate demented, non-demented, very mild demented. So each class, let us see. So in mild demented you can see around 6272 data set images. So you can see all the things that is available in the mild demented. And coming to the moderate demented, there are 4524 images data set in it. So these are all the images that is available in the moderate demented class. Coming to the non-demented, there are around 6720 images that is available in this class of non-demented. And very mild demented, you can see it is around 6272 data set images that is available in this part of the very mild demented. And coming to the test part, you can see the same classes with mild demented with 1344 images, moderate demented with 971 images, non-demented with 1440 images, and very mild demented with 1344 dataset images of for the test. And for the validation part, we have mild demented with 1344 and moderate demented with 969, non-demented with 1440, and very mild demented with 1344 images. So these are the things that is available in the data set part. So now coming back to our project abstract. So this is our project proposed abstract. So as mentioned, Alzheimer's disease is a progressive neurological disorder that severely impacts the memory of it. So early detection will help the patient so that they can plan their treatment and they can improve from their condition. So in this project, we have made the AI powered Alzheimer's disease detection using deep learning, which is a web-based system that is developed using Python as the backend code. And for the web framework, we have used Flask. For the front end part, we have used HTML, CSS, JavaScript for it. And here we have used the image dataset that I showed, that is a MRI brain scan images. So here we have 4 classes, that is mild demented, moderate demented, very mild demented, and non-demented. So as mentioned, the MRI images data set are split into 70, 15 and 15, so that the training, validation and testing sets are available as I showed you. So here you can see the data set is already been pre-processed by applying the techniques such as rotation, flipping and contrast adjustment, so that the model can reduce the overfitting. So here the training set includes the 6272 mild demented, 4524 moderate demented, 6720 non-demented and 6272 very mild demented images of it. So here as mentioned, we are going to use 2 different models, one is MobileNet and the Inception. So MobileNet achieved training accuracy of 99% and test accuracy of 98.35%, while Inception V3 attained the training accuracy of 99.48 and test accuracy of 94.25. So here we have developed a system which is a user-friendly web-based, where that easily even a non-technical person can easily upload the MRI images and they can able to get the results, and that can be exported in a PDF format and they can see the performance evaluations and the graph part of it. So surely this proposed system of AI powered Alzheimer's disease detection will help in the advancement of the AI assisted healthcare, supporting the clinical in early diagnosis and improving the prospects of timely intervention of the patient. So this is all the things that is mentioned in our proposed project abstract part. Coming to the existing system, so now we are going to consider the base paper as the existing one. So here in the IEEE base paper, they have made the prediction and classification of Alzheimer's disease stages using the MRI images, and they have used the advanced deep learning technique. So they have introduced the hybrid deep learning model that integrates the EfficientNet BO and Swin transformer. So existing system workflow is like they have beginning with the pre-processing step, including the skull stripping, bias field corruption, axial slice extraction and intensity normalization. After that, the uniform image quality has been attained, so that they can able to employ that in the deep convolutional generative adversarial network of the MRI images. So they have used the architecture of which combining the efficiency of the EfficientNet for the local feature extraction with the Swin transformer for capturing the global contextual information. So in the existing system, they have used the dataset called Oasis dataset, so where it contains the cross-sectional T1 weighted MRI scans along with the demographic of the clinical dataset. So they have achieved 95.3% of the accuracy. So all these things that has been mentioned in the existing system detailedly. Coming to the disadvantages of existing, so the main disadvantages of the existing system are high computational complexity, long training time, overfitting and generalization issues, dependency on pre-processing, synthetic data limitations, limited interpretability, data set constraints, limited real-time applicability, small data set size, no user implementation, relatively lower accuracy when compared to our proposed system. So these are the things that is mentioned in the disadvantage of existing system, explaining detailedly with the subheading of it. Next, coming to our proposed system, to overcome all these issues in the existing system, we have developed AI powered Alzheimer's disease detection using deep learning. So we have used Python for the backend programming language, HTML is a JavaScript for the front end, and Flask for the web framework. So the dataset contain the brain MRI images, which is split into 70%, 15%, and 15% for the test, validation, and the testing purposes. So the classes contain mild demented, moderate demented, very mild demented, and non-demented images on it. So the dataset images are being trained with the MobileNet and the Inception v3 models. So MobileNet is a lightweight CNN model, so that the optimize it is weight for the efficient training and the testing, and achieved the training accuracy of 99% and test accuracy of 98.35%. The next model, Inception v3, that we have used is known for its deeper architecture and for feature extraction capability. So it achieved the training accuracy of 99.48% and a test accuracy of 94.25%. So the workflow of our proposed system is input images and pre-processing, model prediction, result display, and download it as a PDF format. So all these things that is mentioned in our proposed system part. So coming to the advantages of our proposed system, the main advantages of our proposed system are large and well organized data set, use of data augmentation, high model performance, efficient and scalable deep learning models, multi-class stage classification, web-based user interface, balanced workflow for reliability, and potential for clinical applications. These are all the main advantages of our proposed system. Now let us see the comparison table showing the existing system and the proposed system, so that you can easily identify. So in the dataset part, the existing system uses the OASIS dataset, which is a small dataset, but here in our proposed system we have used a large dataset which contains the 4 classes of mild, moderate, very mild, non-demented. And data augmentation, the existing system relies on DC GAN, and in our proposed we have applied traditional augmentation like rotation, flipping, contrast adjustment kinds of thing, enhancing the generalization also. And coming to the classification capability, so classification both existing and proposed uses the 4 stages also, but existing has the accuracy limitation, but in our proposed system we have done the 4 class classification with higher accuracy and reliability on it. Coming to the model architecture, the existing system they have used a hybrid efficient net BO swing transformer plus attention fusion, which is computationally heavy, but we have used the MobileNet, which is lightweight and fast, and Inception v3, which is deep feature extraction for balanced efficiency and accuracy. Accuracy part, existing system they have used 95.3 and proposed we have used 98.35, and for Inception 94.25. And overfitting risk, here in the existing system it has higher risk for overfitting, but here we have reduced overfitting with large data set. Coming to the pre-processing requirement, so in the existing system it is extensive pre-processing that is required, skull stripping, normalization, slice extraction guys, but in our proposed system we have minimal pre-processing only. Coming to the interpretability, so which uses the GradCam heat map for model explainability, but here in our proposed system we focus on stage-wise description output alongside predictions for better use for user understanding. User interface, the existing system there is no user interface is provided, which is model centric only, but in our proposed system we provide a Flask based web application with HTML, CSS, JavaScript for user access. Finally, practical usability, so the existing system mainly experimental, required high computational result, but in our proposed system it is designed for practical deployment with efficient models and an interactive web interface. Next, coming to the system architecture, so the first thing is like we'll be providing the input of the brain MRI images data set, and then pre-processing feature selection gun, and then just train with the MobileNet architecture and Inception v3 architecture, and the predicted part will be predicting whether it is very mild demented, moderate demented, or non-demented, and finally we show the performance analysis and graph part of it. And these are all the system requirements, these are all the minimum hardware requirements for the project. And coming to the software requirements, this project can be executed in Windows 10 or 11. Coding language uses Python 3.12.0, web framework is Flask, and front-end contain HTML, CSS, and JavaScript. And this is the IEEE base paper reference of it. So now let us see the execution of the project. So first, to open your source code. Inside that we have the Alzheimer disease folder. Inside that we have the app.py other file. So now just type cmd in the address bar. So the command prompt window open with the exact location of it. Now type python app.py. So after some time you can see this URL. Just copy this URL. Go to any of your browser. I'm going to Google Chrome. Paste it. Click enter. So now you can see the project home screen, a welcome screen with the project title AI powered Alzheimer disease detection. So here in the home page you can see the project title with the basic features of high accuracy, efficient, fast and efficient, secure, provide about project features kinds of things. So now let me click the login menu. So now that will navigate to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the sign in. So now you can see the sign in success, and now it will be navigated to the index part, so where you can just select the image and see the prediction result. So as mentioned, we are having two different models. So here you can select the model. For example, currently it is Inception v3. So if you just click the switch model, it will show the option of selecting the AI model whichever is required. So we have two, MobileNet and Inception. So you can see the description of the MobileNet with lightweight and efficient model, and you can see the accuracy that is achieved for this model, and Inception with the accuracy percentage. So you can see this is a MobileNet is highest accuracy with fast and small. You can see Inception with 94.25 with high accuracy, moderate and medium. So currently this is selected, whichever you wanted you can select it. So now let me select this MobileNet and click confirm selection. So you can see MobileNet selected successfully. So now you can see the current model is MobileNet model, and now you need to select the MRI images. Let me go to choose file option. Now go into the project source code location. Inside that we have provided the upload file of sample images. So now let us see all the things one by one. First let me go to the first case of mild demented, and let me select an image. So after selecting the image, you can just click the analyze image. So now it will be navigated to the prediction part. So now you can see the AI diagnosed results of the Alzheimer disease detection using deep learning. So the image that I have selected, and you can see it has predicted the class as mild demented. And here you can see the analysis information. So which model is used, MobileNet, what is the accuracy of the model, when net analysis is made for this image, whether the date and time of it. You can see the clinical information about the mild demented. So this will be varied according to the class that is predicted. So in the mild demented, you can see memory problems and confusion become more noticeable. The individual may have difficulty with the problem solving, organization on recalling the recent events. Assistance with some daily activities may be required. Note, medical evaluation and supportive care are important at this stage. So here we have option of exporting this result in a PDF format for future reference. You can just download this. So just click this option. So now let me save this report for number 1 and save it in the desktop. So now the result is exported in a PDF format for future reference. You can see the AI diagnosed result for it. So it is mild demented. What is the analysis? What is the model used? What is the accuracy? What is the date? And what is the clinical information? And all these things that is being exported in a PDF format of it. So now I'll just go to the analyze another image part. So here you can select another image. I'll just go to the other class. I'll just select an image and then click analyze image. So now you can see the predicted result as moderate demented. So here you can see the same thing of analysis information. You can see the clinical information is cognitive decline is more advanced for the moderate demented. The person may struggle with language, recognizing familiar faces, or performing everyday tasks independently. Behavior changes such as mood swings or restlessness may also appear. Note, at this stage, greater support and caregiving are necessary to ensure safety and quality of life. So similarly, you can just able to export the results. So let me save it as 2. So now you can see the exported result of this case. So now I'll just go to analyze another image. I'll just select for the another case. I'll just select and click analyze image. So now you can see the predicted image result for this image is non-demented. So which means that the brain scan shows no significant signs of dementia. Memory, reasoning and thinking abilities are considered to be within a healthy range for individuals' age. Note, regular checkups and a healthy lifestyle are recommended to maintain cognitive health. So that kind of clinical information is provided for this image. And let me go for the analyze another image. And finally I'll go for the very mild demented. So you can just click the analyze image. After selecting, you can see the predicted result is very mild demented. You can see the clinical information for very mild demented as early signs of cognitive decline are present. The person may experience slight memory lapses such as forgetting names or misplacing items, but daily functioning remain largely unaffected. Note, this stage is often referred to as early Alzheimer disease. So monitoring and early intervention can help slow progression. So now I'll just go for the analyze another. So let me now, before selecting, I'll just switch the model. So I've shown you with the MobileNet model. Now let me select the Inception v3 and confirm the selection. So now I'll just select an image. So this time I'll just go to the images that is available in the training part, and let me select the images so that you can check with other cases also. So now let me select and analyze the image for using the next model of the Inception v3. So now you can see the predicted result is very mild demented with the similar information whatever I have shown you. So now let me go to the analyze another image. I'll just select some other image from the moderate demented part. So there are lots and lots of image. You can check with all the cases that is available. So you can see it is predicted correctly as moderate demented, which is using the Inception v3. I'll just go to the analyze another part. So now let me select some other image from the non-demented part and then analyze the image. So now you can see it is predicted as non-demented. And finally I'll just show you with the other case of the very mild demented using the Inception. And let me analyze the image. So now you can see it is predicted as very mild demented. So all the images whichever I shown is predicted correctly. So here you may have a question that what happens if I'm going to select some other image other than the MRI images. So here the model is trained only with the 4 classes whatever that is mentioned. So it does not know about the other images. So if you're giving some other images, it will be showing the classes of the names that is already present in the model only, because the model does not know about what are other images. So you need to provide the images that is available in the data set only. So if you wanted to give some other images which is not present in the data set, which must be similar to the brain MRI images, so with the same size, shape and everything, if you are giving that, it will be predicted correctly. But you cannot give some other images like human image or pictures or some objects like something. It cannot be able to detect, the model cannot be able to detect, because the model knows only the 4 classes whichever that is trained. So now let us move to the next part, that is the performance analysis part. So in the performance analysis part, you can see the model performance analysis of the Alzheimer disease detection model. So the best model that we have used, that is MobileNet, contains 98% accuracy with excellent speed, and you can see the most balanced is Inception v3 with 95 accuracy with good reliability. So here you can see the model comparison with accuracy of Inception v3 with 95% and MobileNet with 98%. And here you can see the performance metrics with accuracy, precision, recall and F1 score with the Inception and MobileNet model. So you can just go to here and you can select, and you can just see the accuracy of the MobileNet and Inception. You can see the variations of the for the precision, Inception and MobileNet. Similarly, you can see for the recall value of the MobileNet and Inception, and F1 score for the Inception and the MobileNet. And in this part you can see the speed versus accuracy, where you can see the Inception speed and where you can see MobileNet as the greater speed of it. And quick model comparison, you can see the Inception v3 with 95% with the medium speed and MobileNet with 98% is very fast. And for the Inception v3 you can see accuracy with 95%, precision with 0.96, recall with 0.95, recall 0.95 with F1 score. So here you can see the class performance of the 4 classes, where which contains a very mild with 0.89, mild with 0.97, moderate with 1, non-demented with 0.93. So here you can see the details of it. And you can see the for the MobileNet, you contains 98% accuracy and precision with 0.99, recall with 0.99, F1 score with 0.9, and then you can see the class comparison with the 4 classes with the precision recall and the f1 values of all the classes. So these all things that is available in the performance analysis part. So finally let us go to the chart part. So here you can see the model performance chart. So these charts are plotted in the backend models and it has been stored here. So here you can see the inception v3 accuracy chart, and here you can see the inception v3 model loss chart, and you can see the confusion matrix for the inception v3 model. Coming to the MobileNet model accuracy graph, you can see the MobileNet model accuracy graph, and you can see the here this is the MobileNet model loss graph, and here you can see the MobileNet model confusion matrix of it. So this graph part shows the model accuracy chart, model loss chart, and confusion matrix for the both the inception v3 and the MobileNet. So now let me log out. So before completion, let us see about the frequently asked question for this project. The first question is, what is the main objective of this project? So main objective of this project is to detect and classify the Alzheimer disease, which has the 4 stages like mild demented, moderate demented, very mild demented, and non-demented, using the brain MRI images, so that it will be helpful for the patients for the early diagnosis. Next, which technologies are used to develop this project? So we have used backend programming languages Python, web framework as Flask, Frontend contain HTML, CSS, JavaScript, deep learning model as MobileNet and Inception v3. Next question, what dataset is used in the project? So here we have used brain MRI scan images, which contains the 4 classes of mild demented, moderate demented, very mild demented, and non-demented. So which is split into 70% training, 50% validation, and 50% for the testing purposes. Next question, how many images are used for training, validation, and testing? So for training part, mild demented contains 6272, moderate demented contains 4524, very mild demented contains 6272, non-demented contains 6720. For validation part, mild demented contains 1344, moderate demented contains 969, very mild demented contains 1344, non-demented contains 1440. Testing set contain mild demented with 1344, moderate demented with 971, very mild demented contain 1344, non-demented with 1440 images. Next question, what is the role of data augmentation in this project? So data augmentation techniques such as rotation, flipping, and contrast adjustment has been applied in the dataset part previously. So this helps the reduce the overfitting, improves the generalization, and strengthens the reliability of the deep learning model. What are the results achieved by the model? So the MobileNet model achieved the training accuracy of 99%, test accuracy of 98.35. Inception v3 achieved the training accuracy of 99.48 and test accuracy of 94.25. How does the system work? So the user first initially uploads the brain MRI scan through the web interface, so they can able to select the model whether it's MobileNet or Inception v3, and the predicted result will be shown. They can able to export the result in a PDF format also, and they can see the model performance analysis and graph parts also. Next question, can this system be used in real-time medical practice? Yes, the system can be used for the decision support tool, but it cannot be used only tool, but it can be assist the doctors and the healthcare profession rather than the standalone diagnosis system. Next question, why were the MobileNet and Inception were chosen? Why did we choose this model? So this model, MobileNet, is a lightweight, fast, and efficient for real-time application, whereas Inception v3 is deeper, capable for extracting the detailed information, widely used in medical imaging classification, and both the models achieve the better accuracy. So we have chosen those models in it. So who can use this system? So healthcare professionals for diagnosing support, researchers working on medical imaging and AI healthcare, students for academic and project purposes can be used the system. Final question, is the user interface accessible to non-technical user? Yes, the front end is designed with very simple and initiative interface, so that it allows the user to upload the MRI scan images so they can see the predicted result, and they can also export the results in a PDF format for future reference. So these are the frequently asked questions for this project, and this is all about the project of AI powered Alzheimer disease detection using deep learning. And thank you for watching.